Hello, my name is Josh Obrecht, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Edge-of-Field Bioreactors Tool. This is the last tool in the Precision Conservation Siting Practices section of the ACPF Toolbox. Denitrifying bioreactors are an edge-of-field practice where typically a buried bed of wood chips is placed along the edge of a field to intercept a portion of the tile drainage flow. Those wood chips act as a carbon source, so that carbon, plus the oxygen-limited environment, is a good combination for nitrate-reducing bacteria to grow, and therefore leads to denitrification. In ArcGIS Pro, we will open the catalog window in the right side of the screen if it isn't already open by clicking the Catalog tab. Expand our ACPF Toolbox and expand Precision Conservation Practice Siting. Double-click the Edge-of-Field Bioreactors tool to open. This tool has 7 inputs that it's asking for. The first is our field boundary feature class, and we can add that in the first dropdown as it is already in our map. When choosing the field boundary feature class, 4 of our other inputs auto-populate. These are our drainage table, flow accumulation raster, flow direction raster, and our GSurgo raster. The next required input is our unfilled DEM. That's our new DEM, which is also in our map, so we can choose that from the third dropdown. The tool also asks for a z-factor, once again 0.01. The output we're going to get is our bioreactors polygon feature class. Click Run to run the tool. While the tool is running, let's go over how the tool works and finds these ideal locations for bioreactors. First, a mask is generated of all the tile-drained fields based on the drainage table. Then the largest point of exiting flow accumulation, between 20 and 100 acres, is found along the border of those likely to be tile-drained fields. This is our best guess of where a tile outlet may exist. However, field verification will be needed and local knowledge would be valuable to assist in this determination. The next step is watersheds are delineated using that outlet as a pour point. Then a check is done to make sure that a minimum of 10 acres of upstream drainage falls within that current field. Next, the points along those fields are buffered out 100 meters. From those points, areas within 1 meter of elevation are checked for the 2 following conditions: that the area makes up at least 0.5% of the drainage area to that point, and that the mean hydric percent is less than 90. If suitable, a square is drawn that is approximately 0.5% the size of the drainage area. This will provide you an idea of the actual size that your bioreactor would be. The Edge-of-Field Bioreactors tool has finished running, and we can see that the result, a bioreactor feature class, has been added to our map. Let's zoom in and take a look at some of these. It may be hard to tell, but these squares are different sizes. The size is representative of what would likely be built along that field. If we open the attribute table for the bioreactors by right-clicking on it in the table of contents and clicking attribute table, we have the field boundary ID that is associated with each practice, the minimum acreage, which is the size of the bioreactor. Next is the elevation the bioreactor sits on. We have the accumulation value in acres. And each location has a unique identifier from the point ID. The percent hydric soil that's in the area, and all of these will be less than 90%. Finally, we have the XY coordinates of the flow accumulation cell used to satisfy the bioreactor site evaluation. To recap, we ran the Edge-of-Field Bioreactors tool and discussed how the locations are determined. In the next video, we will begin the impoundment siting tools with the nutrient removal wetland tool.